couple of weeks ago, I managed to release the most amazing machine learning model that I've ever had the chance to work on in my entire life. It takes in a number of video frames, passes it through to a machine learning model, which is built in Tensorflow and Python, and is in effect able to go and perform lip reading. That's right, it's able to take a set of videos and transcribe what a person is saying. Now, whilst I'm still waiting for my juicy defense contract, we're gonna take this a step further and build it out into a full stack application using Streamlit, Python, Tensorflow, and a whole bunch of other great Python libraries. Now, this can be extended to a whole bunch of use cases. If eventually you wanted to go and replace the video feeds with a webcam, if you wanted to go and deploy it on a edge device, there's a whole range of possibilities. Plus, this being an absolutely brilliant example of what is possible with machine learning, great for your resume. Anyway, ready to do it? Let's get to it.
Alrighty, so the first thing that we are going to go on ahead and do is get our project opened up inside of VS Code, because we're going to be doing all of the coding inside of VS Code. Now, if you haven't gone and checked out the original tutorial, I'll include a link somewhere up there so you can go and check that out. But all of the code is available on GitHub. So if you want to go and pick this up, you want to get the existing model checkpoints, those are going to be available there. So you can definitely go on ahead and grab those. But now what we're going to go on ahead and do is jump into VS Code. So I'm going to open up the existing folder that I've got and just type in code dot, and you can see we've got a ton of stuff floating around up here. Let me quickly explain this model structure. So over here, we've got our data folder. This was set up in the previous tutorial. We've got our LIPS virtual environment, and we've got our pre-trained model checkpoints. Those pre-trained model checkpoints are available inside of GitHub. I've included the checkpoints for 50 epochs and I think 96 epochs. 96 epochs works absolutely brilliantly, so you can go on ahead and pick those up. We're going to be mainly doing our work inside of the app folder. Now, I've got two existing files. Now, these are going to look really familiar to you if you saw the previous tutorial, because really all we're doing here is we're instantiating our deep learning model, which I went through how to build from scratch in the previous video, and we are going to be loading up the weights. So right down the bottom, you can see that we are loading the existing weights from the 96 epoch checkpoint. So this will give us the ability to run this function here, load model, inside of our full stack application and bring that into our app.
We interrupt your regular programming to tell you that Courses from Nick is officially alive. If you'd like to get up and running in machine learning, deep learning, and data science, head on over to www.coursesfromnick to find the latest and greatest. I'm also going to be releasing a free Python for data science course in the upcoming weeks, so be sure to stay in the know. But if you're ready to hit the ground running, well, I highly recommend you check out the full stack machine learning course. This goes through 7 different projects, 20 hours of content, all the way through full stack production ready machine learning projects. Head on over to www.coursesfromnick/bundles/full-stack-ML and use the discount code YouTube50 to get 50% off. Back to our regular programming. Now, the core advantage of having these existing checkpoints is we're taking a bit more of a full stack feel. This means that we're picking up from the existing machine learning endpoint, right? It's almost as though you've gone and done the entire machine learning engineering bit. You're now passing this off to a software engineer. And it's good practice to get into a habit of learning how to take a deep learning model or take a machine learning model and bring it into a full stack environment and really get it out there into your users. This is exactly what the focus of this particular video is going to be. We're taking this trained deep learning model, and we're going to be integrating it inside of a Streamlit app.
Now, the other helper file that we've also got is this utils.py file. Again, this is coming directly from the existing tutorial. We've got a couple of imports. We are handling our vocab, and we're defining a char to num function and a num to char. This effectively takes our characters that our machine learning model is going to spit out, converts them to numbers. The num to char model or the num to char function does the opposite. It takes a number of tokens and converts them to characters, because in fact, our LipNet model is actually outputting characters.
Now, this is one of the cool things about LipNet in the fact that it is a character-based model. This means that if we were to go and pass through additional videos in the future, it would be able to go and learn how to decode those specific words, even though it might not have necessarily seen that entire word before. There was a question on the previous video about whether or not this is in fact the case. Yeah, it is a character-based model, which is what makes it so cool.
The other functions that we've got inside of here are load video, load alignments, and load data. We're not going to use those specific sub functions. We're going to be using load data, which is going to return to us our pre-processed video and our alignments. Now, again, inside of that bigger tutorial, I actually went through what that actually looks like. And the cool thing is if you actually go and take a look at the thumbnail from that particular video, this actual function was used to go and generate those thumbnails, which is kind of meta. But anyway, I thought that was kind of cool. All right, so we've got two helper functions. So we've got utils.py and we have modelutil.py. We're going to be using those inside of our full stack Streamlit app, and I'll make these two files available inside of the updated GitHub repo, so you can go into that. We're going to be working inside of the app folder. All right, let's actually do some coding now. So I'm going to open up my, we are opening up a command prompt. So I'm going to cd into app. And we are now inside of the app folder. Let's just see that. Can we zoom in? Let me zoom in. So, well, that's very zoomed in.
As you can see, we can't.
Let's zoom out a little. So if we bring that up, you can see that we are inside of our main project folder, and then we're inside of a subdirectory called app. So if I actually go and type in ls, you can see I should have, let's bring this, let's do that again. So you can see that we've got two files in there right now, modelutil.py and utils.py. Cool, brilliant. Okay, so let's actually get to building this app, because right now we've just been messing around and taking a look at what our project looks like. So we're going to create a new file, and we're going to call this streamlit app.py. Beautiful. And then what we're going to do is we are first up going to import a couple of libraries. So first up, we are going to import Streamlit as ST. So this is going to allow us to work with Streamlit. We're then going to import OS, as that's just going to make it whole bunch easier to work with our different file paths, and we're also going to be using it to list out the files inside of a directory. We're also going to import image.io, and that is going to allow us to take a series of videos and convert it into a GIF, which just looks really, really cool. And it allows you to see what our machine learning model is actually going to be able to take in as input before making a prediction. All right, so we've got Streamlit, we've got OS, and we have image.io. We then need to import Tensorflow as TF. What do you reckon? Should I start doing some more tutorials on PyTorch? I've been doing quite a fair bit on TensorFlow, but I know that people like PyTorch as well. Let me know in the comments below. All right, cool. So we've got import TensorFlow as TF. We then need to bring in some stuff from modelutil and utils.py. So we are going to import, actually we're going to, from utils, import, we need load data and we need num to char. Beautiful. And then from modelutil, we are going to load up the load model function, import load model. Alrighty, cool. So those are our 6 key imports that we're going to need now.
Psst, come here. Want to know a secret? Are you looking for your next dream job in data science, machine learning, deep learning, or just data in general? Well, you need to join Jobs from Nick. Each and every week, I'll send you a curated list of the best jobs in data. These are jobs with great perks, great people, and great roles. Plus, you'll get access to exclusive content like AMAs, interviews, and resume reviews. So why not join? Plus, it's completely free. Link is in the description below. What are you waiting for? All right, back to the video. So you're probably thinking, why are we using Streamlit? Why are we using TensorFlow? Why are we using each one of these libraries? Well, Streamlit just makes it ridiculously easy to go and build full stack applications, and it's kind of designed for machine learning engineers, data scientists to be able to take their productionized or their trained machine learning models and bring it into a full stack environment. That's why we're using Streamlit. Image.io, it's going to be about that GIF. So if you don't want to go and create or convert your video to a GIF to be able to visualize it, you don't really need that. But I personally think it just makes things look a whole lot nicer. TensorFlow actually gives us our deep learning capability. If you've got a GPU on your machine, it's going to run way faster. But that being said, you don't necessarily need a GPU, although highly recommend it. Anyway, let's get back to it.
So now that we've got our imports done, so these are all of our imports. So import all of the dependencies. Let's save that. First things first, let's go and try to kick off our application. So we haven't really done much inside of there so far. So I'm just going to open up a terminal. So on VS Code, I typically hit Control and then tilde, which gives me this terminal ability. Right now I'm running it inside of PowerShell, but you can run it inside of a command prompt inside of a Mac OS machine. You're probably going to be doing this inside of your terminal. So what are we going to do? We're going to start up our app. So if we type in Streamlit, and then we are going to type in Streamlit run. Let's make this a little bit smaller so we can see it. Streamlit run, and we're going to run Streamlit app.py. So keep in mind, we are inside of the app folder. So hence why we're able to do this. All right, so if we go and run this, this should open up our Streamlit app inside of a browser, but we're not going to see anything. But let's go on ahead and take a look. That's all looking promising. So this is our Streamlit app. Blank screen, doesn't matter. It's going to work. We are going to build this. Okay, so that is the beginnings of our app. Doesn't look like we've got any errors yet. So we are in a good state. Let's bring this over here. Okay, So now that we've got that done, we should probably start adding a little bit of some structure to it. So let's go on ahead and do that. Let's first up add a sidebar. So we can type in with st.sidebar, and then we're going to add st.image, and I'm just going to grab an image that I personally like. Hold up.
A few moments later.
So I've got this link to this image. It just looks kind of cool. It's got a data and AI feel to it. So if I go and paste that in, that's sort of what it looks like. It shows massive throughput going through a GPU or a bunch of fans. But anyway, you sort of get the idea. So we're going to type in with st.sidebar. This is going to give us sidebar capability inside of our Streamlit app. We are then going to add a title. So we can do that using st.title. And we might call this Lip Buddy. Oh, wow, my typing's a shocker today. And then we can add st.info. So that's going to give us the ability to add some information about our application. So we might say this application is originally developed from the LipNet deep learning. That's my head's covering that now. Deep learning model. Cool. So if we go and save that, let's just make these single quotes. Got a bit of a bad habit of using both. What do you guys do? Let's get rid of that. Beautiful. Okay, cool. Let's go and refresh our app now. We can hit R. Let's open up our sidebar. Boom. Take a look at that. The beginnings of our application. So we've now got the image. So that corresponds to this line here, st.image. We've got the title, which you can see is Lip Buddy. That corresponds to that. And we've also got the info box, which corresponds to that bit down there. So that is the beginning structure of our application now up and running.
So the next thing that we're going to go on ahead and do is start laying out our app and giving it a little bit of structure. So we're going to set up two separate columns. So one column will be able to display the originating video. The other one is going to go through all of our machine learning steps. So first up, we're going to create a little bit of a GIF, which decodes what we're transforming our original video to post-processing. We're then going to have the raw predictions, and then we're going to have the decoder predictions, which take the individual number tokens and convert this into an actual set of words. Before we do that, we actually need to be able to go and get an existing set of videos that we're going to have selected. We're going to use st.selectbox to go on ahead and do this.
So let's go on ahead and start setting out our options. Now, if you cast your minds back to the original video, inside of the data folder, we had all of our videos inside of this S1 folder. Now, there's one thing that I noticed which was a little bit of a pain when it came to Streamlit, in that it wasn't able to play these .mpg files because I think they're an older codec. We're going to solve this using ffmpeg, so I'm going to show you how to do that as well. Okay, let's go on ahead and write a little more code. So far we've done our dependencies, we've set up the sidebar, What we're now going to go on ahead and do is get a list of drop downs for all of our potential options. So here is where OS is going to play. Actually, we're going to do one additional thing. We're going to set the layout to the Streamlit app as wide. So to do that, we can type in st.setPageConfig, boom, and then we can type in layout equals to wide. So this is going to give us the ability to have our page set up to wide. I'll include a little bit of documentation over there so you can take a look at what that means. That is our page config now done. Now let's jump back over to these options. So what we're really doing is we're generating a list of options or videos. So in the future, if we wanted to go and sub this out for a webcam, I'd imagine that this is where I'd be plugging in that block of code. Let me know if we want to extend this app out to that. Okay, so what we're going to do is first up, we're going to get all of our potential options. So let's go and type in options, and we're going to say options is equal to os.path.join. And remember, our options are going to be our videos. So our videos are going to be inside of a folder called, so we need to back out of our app folder. We're then going to go into our data folder, and then we're going to go in a folder called S1. Now, why S1? Well, the original LipNet dataset had a ton of different speakers. I'll include a display of what that looks like. There were a ton of speakers. S1 is speaker 1, but there were a whole bunch of others which were included in the original dataset that was built for the LipNet architecture. We're just using one speaker. Okay, so that is going to give us the file path to that folder. But if we type in os.listia, that's going to give us all of the different options. So if we go and type in print options, let's just go and let's open this up. And let's go and refresh our app. Are we printing out? What's happening here? Can only be called... Set page config can only be called once per app. So we need to go and restart our app. Let's do that. Shut this down and then restart. Good work, okay. Boom, that looks promising. All things holding equal, we should be able to print out all of... Do we have an error there? What's happening? st.pageconf... I think we need to bring this up. This should actually be further up. Let's bring this back up here. Beautiful. So this should be above the st.sidebar. That's my bad. Let's go and refresh that. Beautiful. All right, and you can see here that we're printing out all of the different video names, right? So we've now got a set of video names that we can use as a drop down inside of our app. So to do that, we can then go and type in, we're going to save this as a variable. So we're going to say selected video is equal to st.select box. We're then going to pass through an option, or we're going to pass through a title. Actually, we're going to say choose video, and then we're going to pass through our options to that. So if we go and save that now, we'll bring up our app, hit refresh, boom. So we've now got our sidebar. We've got this ability to go on ahead and choose our video. So later on, when we go and select this video, we're first up going to render it, so you'll actually be able to play it, and then we'll go through all of that deep learning process, which is going to be great. Okay, where are we at? So we've now gone and set up the ability to go and choose a video. So the next thing that we want to go on ahead and do is start setting up that layout, because we don't have that set up right now. So we can first up double check that we've got an option selected. So we can say if options, and then we're going to create two columns. So let's create, should we create it outside of options? No, let's just do it over here. So we're going to say col1 or col1, col2 is equal to st.columns. And then we're going to pass through 2. So I'll include a little bit of documentation up on the screen right about now, so you can see what columns does. But really, this is going to generate 2 columns. And then we're going to say with col1, we're going to do something. And then with col2, we're going to do something. Beautiful. So let's just have some text for now. So if we take in st.text, and we're going to say this is column 1. And then let's paste that over here. And then we're going to say this is column 2. So let's get rid of these pass statements. And let's open up our app back up. So let's refresh. All right, so you can see that we've now got column 1, we've now got column 2. So we've now gone and set up our layout. So just to recap, so we've now got our sidebar, we've now got the ability to go on ahead and choose our video, and we've now got column 1 over here. And if we scroll on over, we've got column 2. So that is the base layout of our app now ready.
Now, the next thing that we're gonna need to go on ahead and do is actually get our video set up so that we can play it inside of Streamlit. I sort of alluded to this a little bit previously in that Streamlit doesn't like the .mpg file format, which is perfectly okay. We can use an extension or a helper library called ffmpeg, which allows us to go and convert this .mpg file into MP4. So we're gonna do that. We're then gonna read in our video, and then we're gonna display it inside of our application so that we are able to go and play it inside of our Streamlit app. We're gonna be using the st.video function. So it's a Streamlit.video display helper function, which actually allows us to go and render this video inside of our application.
Now, in order to get our video up and running, we are going to first up need to grab that video, and we need the full file path. So right now, this is just going to give us the specific file name. We need the entire file path. So for now, let's get rid, are we happy with this No, we don't want this column. Let's actually go and do our magic to get our file. So first up, what we need to do is we need to get the full file path. So we're going to say file path is equal to OS. And the reason that we need this file path is because right now, if we go and choose one of these options, the value selected file over here, or selected video, is really only going to hold this. So bbafn.mpg. It's not going to hold the entire file path to that particular file. We need the full file path to be able to go and do this conversion using ffmpeg. So let's go on ahead and do that. We're just going to effectively append this together. So os.path.join. We are going to then say we want to go back out of this folder. We're then going to go into data. We're then going to go into S1. We are then going to go and pass through our selected video. So that should give us the full file path. Then what we're going to do is we're going to do a little bit of system magic using ffmpeg. So ffmpeg, it does a ton of video processing. So if you've ever used youtube.dlp to get some YouTube videos completely legally,
ladies and gentlemen, we got him.
FFmpeg is actually behind that. So we are going to be converting this. So we are going to say os.system, and this is going to allow us to run a command line call. So we are then going to run the full command line call, which is going to be ffmpeg. We are then going to pass through -i, which will allow us to pass through a file path, and we are going to pass through a string or pass through our variable there. So inside of squiggly brackets, I've gone and passed through the variable file path. So the full line is os.system. Using F, we're able to go on ahead and use some string formatting. We're then passing through or calling ffmpeg -i. We're passing through this variable into our string. So if we closed it, we'd get rid of those errors. But now we need to say what we want to go and convert this .mpg file to. We are going to convert it into a MP4 file format. So to do that, we can pass through -v codec, and it's going to be libx264, I think, something like that. I think that's right. And then we're going to output this file to a file called test video.mp4, and then we need to pass through -yes to say that we want to do that conversion and overwrite the libx2. All right, so let's take a look at that full line. Let me zoom out a little bit. So we've now gone and written file path os.path.join. We're jumping out of our existing folder, going into data, going into S1, and grabbing our selected video. So this will give us the full file path to our selected video. We're then running os.system, and then we're running our ffmpeg conversion to take our .mpg file and convert it to MP4. I know it's a little bit of a effort to go and get to this stage, but hopefully that should make our life easier when it comes to rendering our video. So let's actually go and test this out now. So if we go and, are we still printing out all the file paths? No. Okay, that's much better. We don't want to go on ahead and do that again. So let's, are we still running our app? Let's scroll on down. Looks like we are. Let's just shut down our app and restart. Oh, so that looks like it's running the conversion already. So that looks promising, right? So take a look. We've now got our test video.mp4. So that looks... Let me put my headphones on so I can hear this. I cannot hear anything. Maybe you don't get audio out of whatever I'm playing it in. So let's go into the main folder, which will be inside of here.
BIMblue F2 now.
Cool. So we've successfully gone and converted our video, and these are the original videos from the LipNet model. I'll include a link in the description if you want to go and take a look at the original entire data set. Okay, but that looks promising. So we've now successfully gone and converted it. What we now want to do is render it inside of our application. So we're now going to do some rendering inside of the app. This is pretty straightforward. It's just 3 lines of code to go on ahead and do this. So the first line is, let's grab our video. So we can type in video equals open, and then we're going to be opening up test video.mp4, and we're going to be reading it as a binary. So we're going to pass through RB. So video equals open, passing through test underscore video.mp4 and RB to read it as binary. We're then going to read it. So video bytes is equal to video.read. And then we want to render it. So we're going to use st.video and pass through video bytes. And this should give us the ability to see our video inside of our app. So let's go and rerun our app. Let's close these now. Boom, 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 boom. Take a look at that. That is our video now rendering inside of our application. So we got to play it.
BIMblue F2 now.
All right, let's add a little bit of info, but take a look. So
BIMblue F2 now.
Now, the determining characteristic as to whether or not this is working is if we go and choose a different video, are we going to be able to see that rendering? So if we go and choose a different one, let's choose this one. So BBAL8P means, I think, bin blue at L8, please.
BIMblue L8, please.
There you go. All right, cool. We're looking positive. So it looks like it's successfully converting each one of these videos. Let's add a little bit of information to our app. So just above options, let's add a title. We're going to say st.title, and we're going to say LipNet full stack app. Boom. Beautiful. And then above our video, let's add in an info box. So we can type in st.info. This is display the video below displays the converted video in MP4 format. Save that. All right, let's go and rerun. Beautiful. All right, so we've now got our title and we've now got our info box. So if we go and change our video. Beautiful. I've got that YouTube speed player, hence why it's playing so quick. So we can drop that down to
BIMBLUE L7 soon.
beautiful. All right, cool. That is our video now rendering.
So the video is now successfully rendering, but what we actually need to do is we need to take this video and pre-process it before passing it through to our LipNet app itself. Now, luckily, we've got that utils file, which is going to allow us to load in data simply by passing through a file path. This is going to return back the pre-processed video, which is actually going and isolating the mouth within the original video. So you're actually gonna see the isolated component of that. We're also gonna get the associated annotations for that video. So if we wanted to, we could actually go and compare. Now we've got the video itself, so we can actually see what was being spoken and determine whether or not our LipNet model is actually performing well or not. Now, I'm gonna add in a little bit of flair here, and we're actually gonna take that video and output it as a GIF, which just looks really cool. If you wanted to go and embed this inside a Markdown or share the results or share the pre-processing of this particular video before it goes to the LipNet model, this is exactly what we are going to be able to see right now.
So on to loading some data it is. So let's clean this up. Let's just double check how we're doing so far. So we've gone and brought in our dependencies, gone and set up our layout, set up our sidebar, set up our title, we've got our options, and we've got our column 1, which is all about rendering the video. And then the next thing that we are going to want to go on ahead and do is there's going to be 3 parts to this second column, right? So let's just add in a couple of info boxes. So if I type in st.info, it's one of my favorite Streamlit functions. It just looks really cool because it helps tell your user what on earth they're looking at. I find it so often that people are building different applications and nobody really has an idea as to how they work. Adding a little bit of info just adds that extra little bit of flair and tells your user that you care about them. I just think it goes that little step further. Anyway, all right, st.info. So first up, we are going to display, this is the pre-process GIF, which will this is all the machine learning model sees when making a prediction. Because it's true, right? Like when we actually go and run this pre-processing, that is all our machine learning model is going to be seeing. So the second info box is going to display the predictions. This is the output of the machine learning model as tokens. So our machine learning model actually returns a set of tokens, which goes through a decoder called CTC. It's called Connectionist Temporal Classification. There's a brilliant blog post that I found about it, which actually explains how this works. It's also used quite a fair bit for automatic speech recognition, which I think is kind of cool. So that is what we are going to be returning back. And then the last thing that we're going to do is we're going to run st.info, and we are going to decode the raw tokens into words. And this is where num2char is going to work in. So num2char is going to be helping us there. Okay, first things first, what we want to go on ahead and do is pre-process our data. Oop, I've just kicked my table. All right, so let's go on ahead and do this. So first thing we need to do is load data. So we're going to get back the video and we're going to get back annotations. And to that, we need to run the load data function. Remember, we imported load data right up here. So we're going to be using that now. So the full line is video, comma, annotations equals load underscore data. And then to that, we are going to be passing through the full file path, which we just defined up here. So we're going to take that file path. We are going to pass it through to here. But before we do that, we need to convert this into a Tensorflow tensor, because that is the expected file format that this particular function is expecting. To do that relatively easy, we can type in tf.convert _to _tensor. And if we close that, this will actually return back our video and our annotations. Now, we're not going to stop there. Oh no. What we're now going to do is we're going to take this video and we're going to convert it into a GIF, and then we're going to render the GIF inside of our Streamlit app. I know. So what we're now going to do is use image.io. So image.io.mimsave. To that, we are going to specify what our output GIF is going to be called. So it's going to be called animation.gif. And then to that, we're going to pass through our video and the number of frames per second that we want our output GIF to be. So 3 lines now. So we've got our ST info, which is going to say this is all the machine learning model sees when making a prediction. We're then using the load data function, and this should be convert to tensor. We're passing through our file path, which we defined up here. From that, we're going to get video and annotations back, or the pre-processed video back, and as well as the annotations. We don't really need the annotations, but our load data function brings them back anyway. And then we're using image.io.mimsave to actually go and convert this video into a GIF. So image.io.mimsave. We pass through the name of the GIF that we want to output, we pass through the video, and we pass through how many frames per second we want our GIF to be. Then what we can do is we can actually go and render this inside of our app. We can use st.image, and then we're going to pass through animation.gif, because it's actually going to be, before I do this, let me just show you this working. So if we go and save this, let's go, is our app still running? App looks like it's still running. Let's go and refresh. What should happen if this runs successfully is that when we go and run this, we're going to get a file called animation.gif inside of our app file. So let's go and refresh this just by hitting R. So that looks promising, right? So it doesn't look like we've got any errors. If we go back to our app, take a look, we've got animation.gif. And so the cool thing is that this GIF is all the machine learning model sees when it makes a prediction. How cool is that? No audio is passed. That is all that's being used to go and do that lip reading, which is why I find this absolutely phenomenal. We just need one more line to render this inside of our application now. So we can go and pass through st.image and pass through animation.gif. So if we go and refresh, we should be able to see this. Take a look, that's our GIF there. It is a little bit small, so we can make that a little bit bigger. If we go back into st.image and pass through width equals 400, save that, go and refresh, boom, much better. How cool is that? So we've now got our video playing, we've now got our pre-processed GIF playing. What we now need to do is actually go on ahead and start making some predictions.
Right, so predictions. What we first up are going to need to do is use the load model function that we imported from models util to load up our sequential model, which we originally authored inside of that previous tutorial, inside of a Jupyter notebook. So we're going to load that up. That is also going to load the pre-trained weights, which effectively means that we've got a trained deep learning model to be able to go on ahead and use inside of our application. What we're then going to do is we're going to take the video that we just loaded using the load data function. We're going to pass that through to our model using the model.predict method, and then we're going to take the predictions and pass it through the CTC decoder, which comes from Tensorflow Keras. This is going to help take any duplicate predictions and condense them down. This is the beautiful thing about the CTC decoder. It kind of does all of this tricky decoding for us. Again, that blog post that I referenced previously makes your life a ton easier when it comes to understanding connectionist temporal classification. Highly recommend you check that out. Anyway, let's start making some predictions.
So what we need to do now is load up our model. So that's exactly what we're going to do. Now, keep in mind that we already brought in this load model function from model util. Now, again, that file is going to be available on GitHub, so you can pick that up. You don't need to go on ahead and write it yourself. I just wanted to make your life a little bit easier. So we're going to load in our model. Let's go on ahead and do this. So we're going to say model equals load model, right? And this is going to return our TensorFlow Keras model inside of this variable model, which means we're going to have all of the amazing things that Keras and TensorFlow gives us. We're going to be able to namely use the .predict method to go and make our predictions. So model equals load model. We then want to make some predictions. So we're going to say y hat is equal to model.predict. And then we're going to take this video and we're going to pass it through to the model.predict method. But keep in mind when when we use model.predict, it's expecting a batch of inputs. We only have one input or one example that we're going to be passing through to our model. So we need to go and wrap it inside of another set of arrays. So in order to do this relatively easily, we can just run tf.expand dims, pass through our video, and then pass through axis equals 0. And then we need to close that. So that's going to return our predictions. What we then need to do is we need to go and run this through the Keras CTC decoder. I'll include some information about the CTC decoder up there. It isn't exactly a hugely well documented feature inside of Keras, but there is a little bit of information which I managed to find. So I'll give you a bit of that info right about now over here. Yeah, cool. All right, cool. So now what we're going to go on ahead and do is we are going to take this model or take this set of predictions and we are going to run it through that decoder. So we can then go and take y hat and we're going to pass it through to this. So we're going to set tf, or we're going to set a variable called decoder to tf.keras.backend.ctc decoder. Let me zoom out a little bit. And we're going to pass through the predictions to that. We then need to pass through the length of those predictions. The length is 75. We established this when we created the original tutorial. We're then going to specify what type of algorithm we want to use when it comes to decoding. So we are going to use a greedy algorithm, which means we're going to take the most probable prediction when it comes to generating our output. So we're going to say greedy is equal to true. Now, when you get this prediction back, it's nested inside of a bunch of arrays. So we're going to grab the first value and the first value again. So this should give us what we actually need. So that should effectively be our decoded output. If we go and just print this out, we should be in a good position. So let's quickly recap. So we've gone and loaded our model. We've gone and made some predictions. We are then running it through that CTC decoder. So if we run st, or we're then going to output it as st.text, and we'll pass through decoder, save that. Let's go and refresh this now. So if this works, we should get a prediction in this little space here. So let's refresh. Ooh, we have got an error. CTC decoder. Module Keras API, Keras backend has no attribute CTC decoder. CTC, is it one word? Oh, it's CTC decode, not CTC decoder.
Okay.
My bad. Save that. Let's go and refresh now. Boom. You can see there that those are our outputs. And so this is sort of what I mean. So we're going to be getting back our tokens from our deep learning model. This isn't necessarily a set of words as of yet. So what we actually need to do is we need to go and convert this into a set of words. Actually, before I do that, let me show you what this would look like if I output it before running it through the decoder. So if I type in st.text and just pass through y hat, you'll see the before and after. So we're going to output the raw predictions and then the set of predictions that we get after running it through the decoder. So let's refresh this. Let me zoom out. And you should see that we get a bunch of duplicates. So this is just giving us the raw probabilities back. If we ran it through tf.argmax and we said axis equals 1, let's see what we get back there. There you go. All right, so take a look. So you're getting back a bunch of duplicates, right? So you can see we've got our output 62, 14, 6, 19, 19, 10, 23, 19, 19. So you can see that we're getting all of these duplicates. Additionally, when we go and run it through the CTC decoder, there is a special algorithm which goes and decodes this to get us better sets of predictions, which is exactly the reason that we go on ahead and use this. So you can see that's the raw output. If we were just to go and run it through an argmax function, this is what we actually get back once we run it through that CTC decoder. So we are not going to use this. We are going to use the CTC decoder output. So if we save that, that is our decoder. Now we can also just grab the raw string by typing in .numpy rather than outputting the entire TensorFlow value. So if we go and refresh that, boom, much better. So you can see that that is the raw output out of our machine learning model.
But we're not going to stop there. Oh, no, no, no. What we're now going to do is we're now going to take this set of tokens and run it through the num to char function, which we previously imported from the utils library that we went and created. And this is going to take that raw set of numbers and convert it into a set of words. At the same time, what we're going to do is run it through a function called tf.strings.reduceJoin, which is going to concatenate it together into a single sentence. Let's go wrap this up.
Home stretch now. So what we now need to do is we now need to take this decoder or this decoder output, and we are going to go and decode those raw tokens into words. So first things first, we're going to go num to char and pass it, or not num to chat.
All right, enough chit chat.
And pass through that decoder output. Beautiful. So if we just go and output that, so if I run st.text and pass that through. So just to quickly recap, so we're taking this decoder output, we're passing it through to the num to char function, which comes from up there. So if we go and save our app and let's go and refresh. you'll see we get a bunch of words down here, or a bunch of letters, right? So right now we're just getting all of these letters and we've got a bunch of blank spaces. So that's really difficult to read. So what we can actually do is we can condense this down into something which looks a little bit more sensical. So let's go and do that. So we can go and grab, let's just do it on another line. We'll say converted prediction. And we are going to say, so num to char. We're effectively just grabbing this right now. So setting that to that. And then what we're going to do is we'll run tf.strings.reduce join. Pass that through. And then we're going to take this converted prediction and pass it through our st.text method. So this is coming from Streamlit, just a Streamlit text element. So we can get rid of that comment down here. Let's actually add it up here. So convert prediction to text. Beautiful. All right, so let's go and refresh. All things holding equal, should see magic down here. Take a look at that. Bin blue at L7 soon. Okay, so right now this is still inside of a TensorFlow tensor. We can leave it like this, or we can actually go and clean it up. So if we wanted to clean it up, we can just do, over here, we can type in .numpy. Let me zoom out so you can see this, .numpy, and then .decode, and then pass through UTF-8. Boom. And then if we go and refresh, we're going to test this out. Take a look. So that is our raw prediction. So bin blue at L7 soon. So let's go and play this and see how we're actually doing. So if we go and select a video, let's go and choose one right down here. So LG, we're going to choose this one. So you can see that this is our model doing our video conversion.
Lay green with G5 again.
Oh God, that's way too fast.
Lay green with G5 again.
Lay green with G5 again. And take a look. That is what our model has predicted. Lay green with G5 again. What if we chose another one? Let's choose way further down. What about this? PRAJ1S.
Place red at J1 soon.
Place red at J1 soon. How amazing is that? So we're able to go on ahead, take a video, pass it through this entire pipeline, which has quite a fair few steps, but it's able to make a prediction. Now keep in mind that this isn't using the audio. It's just using the raw video to be able to go and decode what is being said. So crazy. Anyway, let's go and grab another one. What about this one?
Set red at 01 again.
Set red at 01 again. He's got a bit of an English accent. We'll give him that. What about this one?
Bin blue at F2 now.
Bin blue at F2 now. Absolutely amazing. Let's go all the way down. What's the last video? Thumbs DB, that's incorrect. We don't need that one. SWWV9A.
Set white with V9 again.
Set white. All right, so in this particular case, not perfect. Set white with SPS9 again. Not too bad. So maybe we could do some additional training there. And this sort of goes to show that we're not faking this, that this is a genuine set of predictions.
Place white by Q7 again.
Place white by Q7 again. Is that what it said?
Place white by Q7 again.
How cool is that, guys? That is the complete application now done. Now again, all of this code is going to be available on GitHub, so you can go on ahead and check it out. And that is the application now built. So we've gone through quite a fair few steps. We set up our Streamlit framework, we then loaded in our video, and we built through some of those challenges that we encountered, right? So Streamlit can't play the .mpg file formats. We converted it using FFmpeg. We then set up our layout so that we're able to go and visualize our videos, as well as take a look at each one of the steps that our machine learning model is going through. We took a look at the pre-processed GIF, we then took a look at those output tokens, and then we took a look at what had happened, or what happened once we went and converted those raw tokens into a set of words. And that gives us our final application. Let me know what you thought of this tutorial. Hopefully you enjoyed this. I know that we put up the poll determining whether or not we wanted this as a code that episode, or rather as a raw tutorial, but I wanted to give this a little bit more flair, even though we weren't necessarily doing code that. Hopefully you enjoyed it. I will catch you in the next one. Now, as I mentioned, all of this code is going to be available via GitHub. So if you jump on over to Nick Knock Knack and go to the LipNet repository, I'm going to make sure that the entire application is uploaded inside of there. So you can just run a quick git clone and grab that yourself. Let me know if you end up putting this on your resume or inside of your portfolio projects. I'd love to hear all about it. Anyway, thanks so much for tuning in.
Thanks so much for tuning in, guys. Hopefully you've enjoyed this video. If you have, be sure to give it a big thumbs up, hit subscribe, and tick that bell and all that other good stuff. And let me know what you thought of this video. Do you think we should take it a little bit further? Do you think we should make some amendments? Where would you like to see this go? Anyway, in the meantime, I am working on a ton of amazing new sets of tutorials, namely around Transformers, plus the Math for ML course is underway, and that'll all be released on YouTube, so you'll get a chance to get up to speed. Hopefully you're also enjoying the shorts. I've been putting in a ton more effort into those to be able to share a little bit or a couple of nuggets of knowledge that I'm gaining as I'm going through this process and going on the learning journey when it comes to picking up machine learning, data science, and deep learning. Hopefully you're enjoying it. Anyway, I will catch you in the next one. Peace.